So as Teddy said, I work out of Pacific Cascade region, Southwest Washington, essentially Highway 12 south coast out to about Carson area. I'm also in charge of the state's Red Alder upland management program, co-op involvement, research, those sorts of things. And so what I'm going to talk about today, I originally had some grand ambitions about getting this geospatial index finished and all my analysis done before this meeting. Springtime's been busy. We'll get into that a little bit, but I'm going to talk most about that project and another project we've been working on this spring related to Red Alder, young stand management, and site productivity. So Red Alder history, traditionally in the silviculture world, it was not really wanted. We were pretty good at getting rid of it. Through our site prep techniques, slashing, those sorts of things, we did a pretty good job of getting Red Alder out of our conifer stands. It outgrew conifer pretty, in the early stages. It come in real quick, overtop our conifer, not what you're looking for if you're trying to grow Doug fir, hemlock, or another conifer. Way back when, there wasn't a great commercial value for it. And again, it's a pioneer species. It comes in really quick after disturbance. So after weed, log, after something had burned, it would come in really, really quick, and it could be a bit of a challenge. And so we got really good at getting rid of it. Markets have changed though. Commercial value has increased. I was just looking at some of our internal data, and alder is worth quite a bit more than Doug fir. It's in the right areas with the right grades. It is very valuable. It is a high value species. Part of that is due to its relative ease of woodworking. I'm not a big woodworking guy, but from what I understand, you can make it look like almost any hardwood, but it's a little bit softer. It's not super soft to where it dents easy, but it's softer than, say, white oak or red oak, but you can make it look like those other species, so it's easier to work with, but you can get the aesthetics of some of those other species. For us, one of the benefits is a little bit shorter rotation. You can get down to maybe 30 years instead of having your initial stand investment cost taking out, going out over 40, 50 years. It can be a long time to hold your investment. And we also have some disease resistance benefits. Things like Swiss needle cast and certain root diseases don't impact Red Alder the way they do our conifer stands. So what we want when we're managing Red Alder on DNR state lands, my goal is about 20,000 board feet per acre at 30 to 35 years. Currently, we don't have any stands that are pushing that, any planted stands that are pushing that age category yet. But we think we have some that'll make it there, some that are falling a little bit short. That 35-year mark, we might be hitting 20,000 feet to the acre. So we only want to manage productive sites. You can plant whatever you want, anywhere you want, but we only want to do it where it's going to work. As a silviculturist, when I go out and see a little dead trees, that's a bad day. It's a really bad day. So we want to make sure we're only planting productive sites, and we want to keep it operational. Whatever we plant, we have to be able to harvest feasibly. Otherwise, all that investment cost it doesn't make sense to invest that if we can't see the benefit of it. So benefits and risks, financial, shorter rotation. 30 to 35 years opposed to 40, 45, 50, 60-year rotation. However, there's some intensive young stand management cost. It can be more expensive up front to plant Red Alder and go with a Red Alder stand. Policy-wise, when you're planting 3.5 foot tall Red Alder seedlings, you can get your 4.5 foot requirement for green up pretty quick, as opposed to planting a little conifer stand that's going to take you a few years. However, in areas where we have rain on snow constraints, hardwood canopy doesn't count for hydrologic maturity, and so there can be an issue there. And so we have to balance some of those constraints. As I mentioned, forest health, it is an opportunity to mitigate certain diseases, Swiss needle cast, certain root diseases. However, it's very sensitive to frost damage, and we're going to talk about drought stress. Two of the areas we've had some concerns are site productivity and planting stock. So getting into the financials, this is just a quick breakdown of our silviculture cost investment all the way down to net present value of Doug fir and alder. So the green are relatively high sites. For an alder, you're looking at about $4,500 an acre NPV and $4,200 an acre for fir. Those are using some of our PC region cost numbers with aerial site prep. If we used ground site prep, it's same story, just slightly, the numbers are just a little bit different due to those changes in operation costs. But the net present value is relatively similar. I'd argue that those are essentially the same at that model data looking out that far. So financially, it can make sense. One thing to think about though is if we have to do this again at year 0, plant again at $400 an acre, that's going to tank our financials. So survival in those first few years and getting a good stand established is critical. So where we are is, those of you internal DNR know we've had a Red Alder index since about 2007 as a geospatial kind of, we call it a model for Red Alder suitability. Utilized elevation, aspect, slope, topographic position, soil, rock fragment percent, and measured site index, and just produced a site class, high, medium, low, or no potential. When I start thinking about Red Alder, there's one thing in here that's missing to me that is a challenge, and that is precip. You can have great soil, you can have great topography, and everything else that's great, but if you're only getting 20 inches of rain a year, alder's going to struggle. So where we are with stock type, traditionally we've planted a plug half stock type. So it spends its first several months in the nursery, then goes out to bare root field, lives out in the bare root field for I think it's about 5 months. We have some issues with frost damage at our nursery. We get cold winds coming out of the Fraser River Valley that come down and freeze the seedlings before we're able to lift them. And we end up with lots of fall down in the nursery. Those seedlings that we do actually get out to the field can often be damaged to where the survival can be pretty low. It's also a very large seedling, 3.5, 4. We've seen some 6-footers. Packing 6-foot tall seedlings down to the bottom of a unit on 50% slopes that's a challenge. Also have big, long root systems without a lot of root volume to them, and so it can be a challenge to plant. So in 2017, we looked at planting some plug half, plug O's, and 1O's. This was a very informal experiment. Essentially, we had some fall down in our plug half. Our nursery manager started scouting around. He found these 2 other stock types on the open market, brought them in, and we said, hey, we're getting 3 different stock types. 3 is kind of the magic number for experiments, so let's do a little experiment. We planted them out. This year we're doing some other stuff with Styro 15s and plant growth regulators. So our last year we had, this is the Louis VRH timber sale, we had a trial there and a trial there. 3 treatments, 3 replications with each treatment in each location. So we planted all these about this time last year. I went back out last fall to look at these 3 different stock types and how they did over the year. And right after planting, we measured height and stem diameter. And let's see, 0 I believe is dead and 1 is alive. I always get those 2 mixed up. But the moral of the story is it doesn't matter. When you start looking at all of these different metrics, for live and dead, they're the same. We often think about bigger trees are going to survive better, fatter trees are going to survive better. What I saw here was essentially there wasn't much of a difference. There's a little bit of something going on here with height to diameter ratios, but honestly our survival numbers were so low that it didn't really make a huge difference. Where we did start to go with this though was when we started looking at competing vegetation with those trees that were alive and dead. So we have survival, and where we had no competing vegetation, everything did pretty well. Where we had lots of grass, forbs, and senecio, and I think of senecio and grass being relatively heavy water users, our plugs did a little bit better than the others. Kind of made me think maybe plugs might not be a bad idea. So going back to last fall, I go out and I do this survival survey and see that we've got some problems with our red alder stands not doing so good. So it got me thinking about how often do we have issues with survival? How often do we interplant, and what kind of trends might be present? What can I learn from where we've had to replant alder stands in the past so that we can better identify where to plant in the future? So I just queried PC region, mostly because I needed to put a box on it somewhere. We have 2,400 acres of red alder planted down there. So it was a pretty big sample size, and it gave me a box to work in. And on the left, we have the management blocks, the landscape areas, the total number of red alder units, total acreage, and then how many times we've planted red alder in those areas. And so it kind of gives us an idea of how often we interplant. We don't have it in our internal data set. It's kind of tricky to tease out interplants, and this was kind of my best way to do it. But I noticed areas like this lower Chehalis, we have 9 units. We've planted 10 times. To me, that's a 90% success rate. Alocamin, 21 units, we've planted 25 times, over 625 acres. Again, that's, maybe not ideal, but it's looking pretty good. especially when you start looking at Deep Creek, 5 units, we've planted 11 times. The way I look at that is we've had to replant almost every alder stand we've planted in that landscape. And again, adding that extra $400 at the beginning of your rotation, and your financials fall apart at that point. So at the same time, I actually cannot for the life of me remember what I was working on when I pulled this data up. But this is from the PRISM group down at OSU, and it's graphic showing mean annual precip data. And I started looking at where those, kind of thinking in my mind where those landscapes fell. And I was looking at where do we get lots of rain in the region, where don't we get lots of rain? And again, this is the region down here. And what kind of caught me off guard is some of this gorge area actually gets a lot of rain, and some of this area around Chehalis, not very much. Which kind of goes counter to how we often think about things during, especially during the summer seasons. So I took that same information from 2 slides ago now, and wanted to look at how often what's the probability of interplant, and just throw it on a map and take a look at that precip data. And I'm not going to claim any sort of statistical trends here, but it at least caught my eye that some of these really dry areas, we're seeing high probability of interplant. Some of these wetter areas, we're seeing a lower probability. This area up here that is really wet, that is a very rocky site, excessively drained soil at high elevation. It was an experiment of, hey, how far east can we plant alder? We did it once, didn't work very well. Not going to do it again. So I then went back and looked at each of those units that we replanted. So 0 is alive. Growing season precip and mean annual precip. What kind of differences do we have between units we've interplanted and units we haven't? And units that have been successful, we've planted once and we've had a successful stand going forward. They have almost 10 inches more annual precip and 1.5 inches during the growing season. To me, that says something that there might be something here with precip and red alder survival. However, I went back and at the same time, it was, I went through this last fall. Rains were coming back, and I was thinking about this time last year. I don't know about you guys, but I was getting pretty bogged down because I felt like it'd been raining for 4 years. Last winter was pretty darn wet. For those of us in Southwest Washington, not nearly as wet as it is out here, but it was wet. So I looked at the water year of last year and said, we were a bit above average, but we had some major survival problems. So then I went through, and this is all from that PRISM group again, and looked at the traditional growing season, April through September. And here in Southwest Washington, most area we're looking at, we were about average. But the story changes when you start looking at July through September. The joke that I always hear is, it stops raining July 1st or July 4th. And so I figured, at least in Southwest Washington, up until July, we're getting plenty of rain for the most part. We have good soil moisture and all that. And so where we're seeing that drought stress is likely later in the summer. And this may be where we're seeing our drought-induced mortality. And in some of these areas, our research plots are somewhere right in there. So almost in that 50% of average rainfall during that time frame. To me, that made me think we might have something to this lack of precip and mortality. So we've identified there's an issue with our stock type. We have some freeze damage and some climate-related stuff. This is our, holding the camera, eye level, shooting down the rows of our plug half. It's pretty tall stuff. So we started looking at these PGRs as a plant growth regulator. They're originally looking at it for the plug halves, sprayed in the nursery, get them to shorten up before they transplant them, hoping they'll stay short. Works a little bit, but they catch up at the end. So you can apply this stuff, it keeps them shorter, but they respond. So initial thought was, man, this may not have worked as well. But the good thing is that they actually come back. When they start talking about, shortening my trees as silviculturists, I'm getting nervous. Like, guys, if this is a permanent deal, we got a problem. So we started looking at applying it in these Styro 15 plugs. And we have 1 application, 2, 3, and 4 applications in the nursery. So developing kind of a short, fat plug. Control, treated trees. You can see the leaves are different colors. Heights are drastically different. Again, control, treated. We're taking some physiological data with UW. We have a research plot planted at Pack Forest, another one PC region, doing some work with Greg Edel and that group at University of Washington. And just real quick, these are our plug half heights and stem diameters. This is our control and our Styro 15 with PGR. The big one to me is the shoot to root ratio of the PGR is about 0.3, whereas for the plug half it's 1. So we have 3 times as much root on the plug or on the Styro 15 plug compared to stem as we do on the plug half. Hopefully, much greater root volume to stem volume should help us, hopefully, with drought resistance. We'll find out more about that this summer. So, as I said, that state lands Alder Index, sorry, I'm kind of hammering through this here, didn't incorporate Precip. Great tool, built in 07, figured 10 years later, let's update. So look to the 1986, update to 1986, Connie Harrington paper, which incorporates everything we talked about, but also incorporates Precip. So I worked with some of our GIS folks on Natural Resource Building and Division and developed a new version of the Red Alder Index. Steve Kimsey did all the coding for this. And it's on a 3-meter grid using our state lands LiDAR and calculates a metric site index based off that Connie Harrington paper. This is the old one and the new one. There's some dark green here, which is good. It's showing orange in the new one, so that taking Precip into account is kind of toning things down just a little bit. So this is where I got kind of stalled out. I had big intentions of validating this whole thing before I came here, and so I queried our inventory data set for sites where they measured Red Alder site index. Had about 1,300 stands where we have a recorded measured site index in our inventory, and then compared that to what the model calculated. As you can see, I've got some work to do to figure out what's going on. But it's a step in the right direction, I think. Some of the next steps, I'm going to fine tune what I'm doing with our inventory stuff. Again, I just pulled 1,300 units, overlaid them, ran some averages, pulled it out of GIS and said, hey, there we go. I've got a lot more work to do with that. I have run into some issues using these large data sets. I tried to run a process, and I think it was a Monday afternoon I start this process, and it's still running about an hour later. It's time to go home. I go, well, I'll let it run. I'm going to the woods tomorrow. I can let it run overnight. I'm out in the woods about 10 o'clock the next morning, and my phone just starts going nuts, like ringing, keeps ringing. I don't like to answer my phone in the woods, but it keeps ringing. It's our IT guy. Apparently, I filled our entire region server. They said a 200-page PDF would have put it over the edge. So that's we still don't know what happened there. So I've got some work to do there. Conduct field measurements. I do want to go out and actually just apply some random plots and go and do some new field measurements of site index to see if maybe our old FRIS data, there could potentially be some issues there. I'm doing a lot of work with the Oregon State University Hardwood Silviculture Co-op. They have a lot of field data as well. And so we're going to utilize that, overlay it, both their co-op plots and other areas. So we're going to do a lot of more validation there. We're thinking about trying to incorporate some financial information to it. And the big one that I'm really excited about is this non-DNR lands. I really like what I do working on state lands, but every now and again I wish I could have a little more impact to the others around us. And I've been talking to the co-op about, and our GIS staff about, and the way we wrote the code was with this in mind, with the idea of being able to take the work we did to develop this index and hand it to the co-op, and then they can use a USGS DEM. We used our internal LiDAR, but they can use the USGS DEM and run it for all of Oregon and Washington. So this will be a tool that will be available to the public for Red Alder, kind of a Red Alder site index prediction, which I think could be a big benefit to some of the small landowners. So this is a district manager planting trees. I know it's rare, so I like to show that picture. Just quick thanks to a lot of the field staff that helped me. I had a lot of folks out planting trees and measuring stuff, biologists, district managers, foresters, all kinds of folks. Also the folks at the OSU Hardwood Silviculture Co-op, Steve Kimsey, and then John Trobaugh, Nabil Kaduri, and Kyla Benj at Webster Nursery have been a huge help. Nabil's really running the plant growth regulator stuff, and he's been fantastic.